Very good. Today we're going to talk about hypothesis testing for two populations. This is the scenario that you are interested in comparing two populations together. So you have the very first population, population number one, for example, San Jose State University population, and population two, for example, Stanford University students populations. You're interested in comparing these two populations by asking different questions. For example, you might be interested in knowing, well, is there any difference between average GPA of students in San Jose State University and Stanford University? These are the types of questions that we usually ask when we have two populations. As a statistician, what you're going to do, you're going to take random samples from these two populations. Sample one, and then you're going to take sample two from the second population. Well, once you take random samples from these populations, there are some numerical characteristics that you can assign to these two populations and also the samples. For any population, you have population mean. Population mean is denoted by mu. So since we are using the very first population, I'm going to put mu sub 1. And for second population, we're going to use mu sub 2. Each set has a standard deviation. So sigma sub 1 is going to be standard deviation for the first population. And sigma sub 2 is going to be the standard deviation for the second population. Remember that we took random samples from these two populations. For the very first sample, we can also compute its mean, x1 bar. It also has a standard deviation, so S sub x. Mean of the first sample, standard deviation of the first sample. For the second sample taken from the second population, you also can find its mean, x sub 2 bar, and also the standard deviation. Very good. So what are we going to do with these two pieces of information taken from population 1 and population 2? We can actually run and check hypothesis testing for two populations using two samples. The very first scenario is when we have the hypothesis testing. So you form the null and alternative hypothesis. In the null hypothesis, you might end up having the scenario that mu1 is equal to mu2, or there is no difference between these two populations, while the alternative, which is the complement, mu1, is not the same as mu2. Remember that we can divide this up into three different cases. The null hypothesis in the second scenario, the second case, that mu1 is more than or equal to mu2, or the difference between mu1 and mu2 is more than or equal to 0. Its opposite, mu1, is less than mu2. And finally, the last scenario that you have is you're going to end up with a right test, as you remember. The null hypothesis says mu1 is less than or equals to mu2, and its complement or its opposite, mu1, is more than mu2. After we identify the null and alternative hypothesis, we're going to find the standardized statistic. Just note that, so as we mentioned, we're taking two samples from two populations. Make sure these two samples are independent from each other. So, independent samples. What do I mean by that? So, for example, the first population is San Jose State University students, and the second population is Stanford University students. Students that are going to San Jose State University are not attending Stanford at the same time. So these two samples are definitely independent from each other. Or people who live in California right now are not living in Illinois. So you have two independent samples. Perfect. So what about standardized test statistic? You need to follow the formula. The formula says, hey, find the difference between sample means x1 bar minus x2 bar minus find the difference between population means mu1 minus mu2. Note that this guy is going to be 0 divided by standard error. Standard error is the square root of sigma sub 1 squared divided by n1 plus sigma sub 2 squared divided by n2. After finding z, as we did before, we're going to find the area. To find the area, you can use normal CDF. We practiced a lot. Again, when do we use normal CDF? When we have z. When do we use z? When we have the standard deviation of population. Sigma is given to us. After finding the area, we're going to find the p-value. Find p-value. And at the end, we compare p-value and alpha. If p-value is less than equals to alpha, you're going to reject the null hypothesis. So these are the steps that we're going to take analyzing hypothesis testing for two populations when sigma is given to us. Very good. Let's go over one example together and try to use what we learned here. In this example, we have a credit card watch group. So let me write down the example up here for you. A credit card watchdog group claims. Okay, guys, we have a keyword here. Claim. They claim that there is a difference between the mean credit card debts of household in California, households and Illinois households. Very good. We are a statistician. We say, well, we need to do a little bit of calculation to understand what's going on. We're going to send one group to California and another statistician group to Illinois to collect information. So our statisticians go to California and Illinois, these two states. They collect information from 250 households in each state. This is the information that they got. In California, they found out that the average credit card debt is, let me follow our notes, is $4,777. And in Illinois, it is about $4,866. We also found that the standard deviation in California from past studies is, let's see, 45, and in Illinois, it is $1,350. So this is the information that we have. These are the pieces of information that we collected. First, let us write down the null and alternative hypothesis. Another keyword that is important for us here, it says, there is a difference. When we say there is a difference, it means that they are not equal to each other. So there is a difference, they are not equal. So what's the meaning of that? It means that we have a two-tailed test. It means that our alternative hypothesis is the claim mu1 is not the same as mu2. So you can automatically write null hypothesis. Mu1 is equal to mu2. You have a two-tailed test. It means that your rejection region has two parts. One part is on the left, and the other part is on the right-hand side. I'm right. Very good. So let us do the computation. Remember the formula. Always remember the formula and write it down. It's very important to know which formula to use. First of all, note that since sigma is given, Z standardized test statistic is x1 bar minus x2 bar minus mu1 minus mu2 divided by the standard error, which is the square root of sigma sub 1 squared over n1 plus sigma sub 2 squared over n2. So this is the formula that you need to remember. It's important. Let's punch all of this information into this formula. So x1 bar is 4,777 minus x2 bar is 4,866 minus, it says the difference between the population means. The difference is going to be 0 divided by the square root of sigma sub 1 squared. Well, what is sigma sub 1? From past studies, we know that the standard deviation of California is 1,045 to the second power divided by n1. How many households? In each state, we ask 250 households divided by 250 plus. Sigma sub 2 squared, sigma sub 2 is for Illinois. It is 1,350 to the second power divided by n2. We ask 250 households in each state, 250. So let us do the computation. What is this number? Take your time, pause this, answer the question. It's useful to work with calculator at this time. So as you calculated this correctly, it's about around this negative 0.8. So this says, hey, your standardized test statistic, negative 0.8 is right here. Very good. So after calculating Z, you need to find this little area. To find this little area, since it is Z, you're allowed to use normal CDF. Normal CDF. The lower bound is a small number on the left-hand side of negative 0.8. Let's use negative 10. It stops at negative 0.8. The mean is 0 with standard deviation 1. If you do the computation here, it's going to be about 20%. Okay, so it says, hey, this little area here is about 20%, 21%. Now we need to find p-value. P-value, some part of p-value is on the left, the other part is on the right. So what are we going to do? We're going to multiply this 20% by 2. It's going to be about 40%. So it says, hey, my p-value is 40%. Now we compare p-value, which is about 40%, with alpha. Well, it didn't give us any information on alpha. and alpha is missing, you by default select 5%. So obviously, p-value is more than alpha. Since p-value is more than alpha, we fail to reject the null hypothesis, or we support the null hypothesis. We support null hypothesis. It means that we reject the alternative hypothesis, but the alternative hypothesis and the claim are the same thing. So we reject the claim.